Our next speaker is Shancong Mou from the Industrial and System Engineering Department, and I'll ask Murthy Salapaka to get ready.
Thanks for the introduction. So today I will talk about one of the application we have been working with a group of manufacturing experts and material scientists to optimal design this composite adhesive joint process. So these composite materials actually are widely used in lots of different industries, like this kind of like supercar, right, and aerospace. So some of the, if you want to connect those two pieces of composite material together, a widely used approach, right, is to use these adhesive joints, right? So in this case, it's very important to evaluate or predict the quality of your adhesive joint, right? Because this thing gonna fly with the airplane, right, together. And a group of manufacturing guys and the material scientists, they come to us, say, okay, now what we are doing is we do lots of purely experiment-based. So that is, they have a very complex multi-stage manufacturing process to kind of produce this joint, this adhesive joints. So you can see they have like the stage of material preparation, and then a set of like the composite material manufacturing, and then you glue them together under a specific set of pressure, temperature, and then finally you get a panel, right, that was glued together. But before you're going to use it, you have to go through a destructive test process to really test, okay, how much strength I really need to break this joint. And only when the strength is above like a certain level, then you will say, okay, this is safe, right? So you can see this is a labor-intensive and expensive process. So they're asking, okay, can we build a predictive model, right? If I tell you what are those manufacturing parameters, like the temperature, right, temperature field actually, the pressure, right, and all different manufacturing stages, parameters, can you just tell me, okay, how much strength I'm gonna have of my my material, the manufactured composite adhesive joint, right? So this becomes a kind of predictive problem that you try to, the input is the heterogeneous manufacturing parameters from a different pressure, temperature, and finally, we want to predict that the destructive test curve, right? Because this curve really reflects the material property we have. So how to do it? So we try to integrate, right, the existing material kind of property equations, right, that describes how this test process works. You apply a specific force to the structure, right? And then the deformation of the specific structure gonna follow a set of physical equations. But here, this is the one-dimensional physical equation because for a real kind of 3D structure, it's very difficult to model that. But luckily, we will have some experiment data. So the question becomes, how can we integrate the physical equations with the set of like experiment data to achieve best model, right? So we develop kind of physics-informed neural ordinary equation model to achieve this goal. And here is actually the result. So the red curve is the prediction performance of the model, and all the other different colors are competitive methods. So you can see, one thing I want to mention is actually, if you incorporate the physics equation into the modeling process, you only need about 10 experiment data points to achieve relatively good performance. So this is really something we want to, because we don't want to do lots of experiment, but we're still looking for a good prediction performance. So this is one of the experiments we have. Okay, thanks.